continuing where we left off from our 8.1 video, we just finished a few examples, a few things to talk about. Conditions for constructing a confidence interval. We talked about two of these conditions in the previous chapter, back in chapter 7. We talked about how to test for normal condition and then also for the independent condition. So the new one is our random condition. We need randomness for population or cause and effect inference. Okay, so that's kind of what we talked about back, I think it was chapter 4. So our data should come from either a well-designed simple random, or random sample, I should say, or a randomized experiment. So margin of error only covers for chance variation, not for bias like undercoverage or non-response. So you have to get your data in a legit way. Margin of error just covers for the whole idea that there might be some chance variation. To test for normal, it's going to depend on if it's for proportions or for means. The methods of calculating confidence intervals rely on normal sample proportion or sample mean sampling distributions. So when it's proportions, you need to make sure that n times p and also n times 1 minus p are both greater than or equal to 10. And then for means, the central limit theorem says that n has to be sufficiently large, so we say at least 30, or it has to state to begin with that the population distribution is normal. So depending on what you're doing a confidence interval for, you need to test one of those two things. For independent, the individual observations have to be independent, right? If this condition isn't met, you can't calculate the standard deviation of the sampling distribution, which is part of the formula for confidence intervals. So if it's not independent, you can't calculate your standard deviation of the sampling distribution. The 10% condition says that the sample size should be no more than 10% of the population size. So you have to talk about that. So a couple more things, and then we will wrap up this section. So some interval properties, okay? How can you make a smaller margin of error, right? Say you want to have a smaller margin of error. Well, there's two ways that you can get a smaller margin of error. One of those is to decrease the confidence level, okay? If I'm not as confident, I'm not including as many values, right? Another way you can do it is if your sample size, n, increases. Okay, so you can see from these graphs here, as your sample size gets bigger, your interval's getting smaller, and then also as your confidence level is decreasing, your margin of error is also getting smaller, and you can see right there. One last thing. The critical value depends on the confidence level and the sampling distribution. So greater confidence requires a larger critical value. And then the standard deviation of the statistic depends on the sample size n. So you can see here, more confident, more values. More values in my interval. So that wraps up the basics of 8.1. The next sections will actually show you how to calculate confidence intervals for proportions as well as means.